Rahim. During last lecture we started with Fourier transforms. Now what is Fourier transform? It is the transformation of a given function f(x) into a new function fk through transforming function e raised per I k x. So it is basically the change of fx into fk through equation number 1, and the important thing is to solve this integral. Now equation 2 is similar to 1, but look here this function, which is the transforming function, it is e raised per minus I k x, and that is fk. So it means that if fk is given to you, you can transform it back to fx through this transformation. Hence this is inverse of this, and similarly this is inverse of that. This transforms fx into fk, and this transforms fk into fx. So they are inverse of that, of one another. Then you can expand it as cosine kx plus I sine kx, and by certain consideration which I explained last time, you can get what is known as Fourier cosine transform. And look at the limit, it is no longer from minus infinity to plus infinity, it is from 0 to infinity. It is transformation of the function of x with the help of the helping function cosine kx, and you get the Fourier cosine transform of fx. Similarly, fck, if you put it here, this is Fourier transform, Fourier cosine transform, because it is transforming it with the help of cosine kx of fck to fcx. So it is going back. So they are inverse of each other. Now similarly, if you come here, then it is Fourier sine transform of a function fx into fsk with the help of sine kx, which is the helping function, and you get the transformation of this fx into fsk. Similarly, you can have transformation of fsk with the help of sine kx into fsk. So these are inverse transform of each other. Now as far as equation number 1 is concerned, last time we took an example and we saw how to get the Fourier transform of a given function. Now this is yet another example. Here fx is equal to 1 between 0 and 1, and fx is equal to 0 when x is greater than 1. And he is saying, okay, find Fourier sine transform of this, and then find Fourier cosine transform of that. Now remember, if you look, you have to plot first the graph of these, and if you look at the graph of that, then it is like this. This is your x, this is your fx, right? And that is your 1 value, 0 to 1, this is 0 value, this is 1 value, this is fx is equal to 1 value. Now what he is saying if you put x is equal to 0, fx is 1. If you put x is equal to 1, fx is 1. If you put anything between 0 and 1, that is here, it is still 1. So it means that your function starts from here, but since here is no equality sign, so it will just end little bit before x is equal to 1, and for remaining value it is 0. So that is the graph of that. Now the next thing is find the Fourier cosine transform. Now Fourier cosine transform is equation 4. Equation 4 is, it says fk is equal to 2 over pi square root 0 to infinity fx cosine kx dx. Now it means it is equal to 2 over pi square root 0 to 1, 0 to 1, 0 to 1. What is the value of x? It is 1. Cosine kx dx plus 1 to infinity, that is greater than 1, it is 0. So it is 0 into cosine kx dx. So this is gone because that is 0, and you just solve that. It is equal to 2 over pi square root 0 to 1 cosine kx dx. You can solve this integral. You can solve this integral, and your answer is 2 over pi square root, and integral of cosine kx is equal to sine kx over k, and limit is 0 to 1. And if you substitute this limit, then what you get, 2 over pi square root, and that is sine k over k when x is 1, but when x is 0, sine 0 is 0. So that is the Fourier cosine transform of this function. Now similarly, you can find the Fourier sine transform. Okay, that was the a part of that. That is how you found the Fourier cosine transform. Then similarly you can find the Fourier sine transform by the same method, and you do it on yourself because it is a solved example given in the book, so I am no longer going to do that. Okay, so that is one thing. So have a practice of these. Okay, look at the problem in the book which are solved or unsolved to find the Fourier transforms, and have a practice for the examination. Okay, so that is your job to do. Now we come to a next thing. The next article is Fourier transform of derivatives. Fourier transform of derivatives. Now you see, what does it mean? Fourier transform of derivatives. So that is the article. Now you know the Fourier transform of a function fx is given by 1 over 2 pi square root minus infinity to plus infinity fx e is for ikx dx. That is the standard form of the Fourier transform of transforming a function fx into fk. Okay, this is one. Now instead of taking fx, we take derivative of fx, we take derivative of fx, derivative of fx for fx in equation 1, because we are going to find the Fourier transform of derivative. For fx we are going to put that. Okay, so let me put it that, and in that case this expression is fk is equal to 1 over 2 pi square root minus infinity to plus infinity d of fx d of fx over dx e raised to I k x dx. This is equation 2, and since it is, we have put derivative there, therefore I will put here 1 because it means it is derivative of fx. Then I take this as u and this as v. Open this integral by u into v method, that is integrated. You get f1k is equal to 1 over 2 pi square root u into integral of this. Look, integral and derivative cancel, and what you get is fx. Okay, they will cancel. Limit is minus infinity to plus infinity minus integral of derivative of x, derivative of u, which is e raised to I k x into I k, into integral of this, which is fx dx. Okay? Or if this is the condition imposed on that, fx tends to 0 for x tending to plus minus infinity. Now it is very important. It means that if you put this limit here or this limit, then this should approach towards 0. Then this will, the first part will be 0. This will be 0. That is, if you put x is plus infinity or minus infinity here, then fx should tend towards 0, and you get f1k is equal to minus ik, because this is minus ik, this is 2 pi, which is with that as well, minus infinity to plus infinity e raised to ikx fx dx. Okay, this is equation number 3, that is this one. Now use equation 1. Now use equation 1 in equation 3. Look, so what I am going to do, f1k is equal to minus ik over 2 pi minus ik into 1 over 2 pi square root minus infinity to plus infinity fx e raised to ikx dx. Now what is this? This by equation number 1, that is this one, you can write it as f1k is equal to minus ik into fk. That is, the first derivative is there. You are going to find its Fourier transform of derivative of fx, and you see, you come across with the Fourier transform itself multiplied by minus ik. That is, just multiply. You don't have to do all that process if somebody says find that, but you will just write it like this one. And similarly, if you are talking about nth derivative, then this will be minus ik raised to the power n fk. That is, if there is double derivative of this, then it will be square here and it will be f2. triple derivative, then it will be n is equal to 3, and then you don't have to solve that integral, because this derivation, it provides you a way how to find the Fourier transform of derivative. The answer is multiply Fourier transform which is given to you just by minus ik, and that will be the Fourier transform of the derivative. Okay, so this is how this is done. Now I am going to take a next example. Now I'll not complete it, but it will be, just helpful for you people to solve problem on your own. Okay? This is problem 8.16, page 208, Advanced Mathematics. Number 1, A. Find Fourier transform. Find Fourier transform of fx is equal to 1 minus x square, x is less than 1, 0, x is greater than 1. B. Evaluate 0 to infinity x cosine x minus sine x divided by x cube cosine of x over 2 dx. Look at the graph. Graph says this is x, fx, x both positive and negative value 1. This is plus 1, minus 1. It means that in between this, it is behaving like this. When x is equal to 0, this function is 1. When x is 1 over 2, then this becomes 1 over 4, and you get 3 by 4. Okay, 3 by 4. This is 3 by 4. Right? Similarly, for minus 1 over 2, you get that one. And similarly, when x is 1, then it is 0, that is 0. So you will have like this, or maybe curve in between, I don't know, but graph will look like that one. Okay, now let's find its Fourier series. A part, it says fk is equal to 1 over 2 pi square root minus infinity to plus infinity fx e raised to ikx dx, which can be written as 1 over 2 pi square root minus 1 to plus 1 minus x square e raised to ikx dx. Now remember, integral starts from minus infinity to plus infinity. So first you will write an expression कि भाई 1 over 2 pi minus infinity to minus 1, and from minus infinity to minus 1 function is 0 dx. Then you have from minus 1 to plus 1 function is this, okay, function is this one. Then from 1 to infinity, again function is 0. So you have only that thing. This can be split into two portions. This can be split into two portions. Fx is equal to 1 over 2 pi square root minus 1 to plus 1 e raised to I k x dx, then minus 1 over 2 pi square root minus 1 to plus 1 x square e raised to I k x dx. Now you know the integration, limits are very simple. If you solve it, then put the limit, your answer will be, this is after integration. After integration. After integration, you get Fk is equal to 4 over 2 pi square root sine k over k cube minus cosine k over k square, that is, that is the Fourier transform of Fk. This is the Fourier transform of Fk, and for the B portion, I am leaving it for you to solve it. Evaluate that. What you have to do, you will be using, we have find Fk, so you will be using inverse. This is cosine transform of that, and you will say that Fx is equal to 2 over pi square root 0 to infinity Fk cosine kx dx. Now why haven't we used the sine transform? Look, it says transform this, find this integral, and you see cosine here, it means definitely you have to find the cosine transform of this. Now had it been sine x by 2, then you were going to find the sine transform of that one. Okay, so this is Fk. Okay, this is Fk, I mistakenly written. So what you will do, you will substitute for Fk this thing, open it and try to solve the integral. So you will put it there, you will open it and try to solve the integral, and you will get the answer, and answer to this is 3 pi over 16. Okay, try to complete it, take it as an home exam, home assignment. Okay, so I finish it here, and then next time we'll do some more thing in your course. Thank you very much for listening. बस बंद कीजिए.